we basically are focusing on the graphical part of differentiation, which is the ending of differentiation, and which basically gives an overall perspective of what differentiation is used for as a primary purpose, and how do we evaluate any graph, any chapter, any subject, and how basically we can plot a graph even if we don't know the chapter functions properly. Just by calculus, find the tangent equation and identify how that it is varying, and also identify where our maximas and minimas are there. Okay, so for example, let's say we were doing the third degree polynomial, right? So suppose we have y is equal to x cube plus 2x square minus 8x plus 16. And the question is, find the maximum value y max or the minimum value. Procedure is simple. We first differentiate the function y, find dy by dx, and dy by dx we will get it as 3x square plus 4x
minus 8.
For maxima or for minima, we equate this fellow to 0, because at maxima or minima, the slope of tangent is 0. dy by dx is 0. So now, because we got an equation, we will basically get the roots of it. So minus b plus or minus root over b square minus 4ac. So 12 8 is what? 96.
Yes.
Divided by 2a. So under root of 96 plus 16 is 112.
Plus is 6. 112 is not a perfect square.
112 is not a perfect square.
It's not, yeah.
121 is 11 square. 100 is 10 square.
10 square.
112 is more or less in between. So we will approximate it to 10.5.
Okay.
Okay. So we have, or we'll make it 10. So 10 will be basically too low. We'll take it as 10.5. So we'll get this. So here I have two possible values.
Yeah.
So one value is minus 14.5
by 6.
by 6, which is again approximately 6 2s are 12, 6 4s are 24. So approximately
2.4 minus 2.4.
Minus 2.4. The other value x2 is 6.5 divided by 6, which is approximately 1.09.
1.8. Oh yeah.
Is it 1.08? I think, right?
Yeah, 1.08.
We got two values, x1 and x2. Now, what shall we do? We found out where our maxima and minima are possible, but we are still not sure which is the maxima, which x is representing maxima, which x is representing minima.
Minima.
Correct? So to know exactly, I will double differentiate the original function. I will get it as 6x plus 4.
Also.
3x square plus 4.
6x plus 4.
Okay. And now substitute these x values that I got in this particular double differential. Fine?
Yes.
So for x1 is equal to minus 2.4. Actually, if you see...
Minus 14.4 plus 4.
Correct. Minus 14.5 plus 4 is minus 10.5. And for x2 is equal to, I'll substitute 1.08 in this. So it is 6.5 plus 4. So this is f double dash of x. So f double dash of x, how much will I get?
1.08 into 6. 6.48 plus 4, so 10.48.
No.
The values are coming approximately same.
Actually, if you see 6 into 1.08 itself is 6.5, which we originally had it.
Yes.
6 into 1.08 is nothing but 6.5. So
Yes,
I'll
yes,
substitute
yes.
this as 6.5 plus 4 is 10.5. I thought you did this one also the same way, the first one. 6
I did
into
not.
6 into 2.4, it's basically our minus 14.5. I'll substitute minus 14.5 over here. This is minus 14.5 plus 4. That's why I got it directly as minus 10.5. I thought you
Minus
already
10.5.
did that. Yeah. You gave the
Right.
answer so fast. Nice. So, great. So, for x1, I got a negative value. And for x2, I got a positive value. So, if my double differential is a negative value, it implies
then it's maxima.
It's a maxima. That means for x1, I have a maxima. And for my x2, I will have a minima. And I also know where this maxima and minima are occurring. It is at x is equal to minus 2.4 and 1.0.
Minus 2.4 and 1.0, right?
So specifically, if I want to find what is the maximum y value, I will substitute minus 2.4 in this whole cube, in this polynomial. So basically, I'll have minus 2.4 whole cube plus 2 times 2.4 whole square minus 8 times, or it is minus 2.4 by the way, plus 16. And for y minima,
yes, 1.08.
I'll substitute 1.08. So 1.08 whole cube plus 2 times of 1.08 whole square minus 8 times of 1.08 plus 6. So we'll get some values. You don't have to solve it right now. Eventually, we will get some values is what is for sure, right? If we know the values, we can plot the graph even better. At x is equal to 0, y is 14, y is 16.
Yes.
So we know that also. Although nobody will ask you to plot, but I am just showing that at x is equal to 0, y is 16. So curvature has to pass through this point for sure.
Yes.
Okay. This point is 0, comma 16.
16.
Next. My maxima is occurring at minus 2.4. So that means somewhere over here at minus 2.4,
yes,
I have a maxima.
Yeah.
And my minima is occurring at x is equal to 1.08. Somewhere like this.
Yes.
Now, approximately I am going to plot it. We don't know the y values. If we get the exact y values using calci or whatever, we can plot it in fact in a very more closer way. Okay.
Accurate way, yeah.
Okay. So I am basically figuring out that it has to pass through this. So basically it should come like this, where minima is at 1.08. And because it has to pass through this, it will go like this, and where maxima is occurring at minus 2.4. So the curvature has to look like this.
Yes.
The curvature has to look like this. Maybe this comes lower. Maybe this minima comes lower. Maybe my y min will come out to be negative. Maybe this y max will come out to be more positive. Definitely, y max is not less than 16
Yes.
because it is 16 plus of something. My maxima has
Yeah.
to be greater than 16, right? This entire thing is something plus 16.
Yes.
Unless and until that remaining something is negative, then 16 itself becomes my maxima in that case also.
Yeah.
Correct? If that entire thing
Yeah.
is always negative, then at x is equal to 0, I should get my maximum. Which basically I am
Yes.
concluding that my maxima is greater than 16. My maxima is greater than y is equal to
Greater
16.
than 16.
And it is occurring at minus 2.4. At x is equal to minus 2.4, it's occurring. So that means this fellow has to
Yes.
go up. And this fellow has to come down.
Yes.
And we got only two values for x. That means either one maxima and
Yes.
one minima are only possible. If I get three values, then I can say two maxima, one minima. One maxima, two minima.
There can be two maximas and two minimas. Can there be
Why
multiple
not?
maximas and minimas?
Why not? For example,
So it will come at the same point though, right? But like the height will be the same, the point will be different.
for this
like,
curvature,
y-axis will remain the same.
you're saying for this curvature? For this particular example, you're asking?
For any, like
For
in
any,
general,
right? For any.
if there's multiple maximas,
I'm showing it.
then how will it look?
For any, basically the graph can be anything like this.
Yes.
And not necessarily all the minimas have the same value, right?
Okay.
Not necessarily all the maximas will have same value. Y value for maximas.
Yeah.
This is also called a maxima. This is also called a maxima. This is also maxima. This is also maxima.
So then how are we supposed to calculate it if it's all in one graph?
Same procedure. When you differentiate
So we
it,
take the individual curves. We don't look at it as one whole thing.
I will tell you one thing. In this particular graph, how many maximas are there? 1, 2, 3, 4.
Yes.
How many minimas are there? 1, 2, 3.
Also 4, I think. Okay, 3.
Correct? For this
Yes.
particular graph. So my first differential, when I equate it to 0, how many solutions of x should I get? How many values of x should I get?
7.
Correct?
Yes.
That means this graph should be something y as a polynomial of x to the power 8 at least.
Yes.
Can't be 9 because then 8 will be possible.
It will come, yeah.
Can't be 7 because if I differentiate, I'll get
Only
x to the
6 will
power 6.
come.
It has to be a function of 8th degree polynomial, which will give me 7, in which some will be maxima, some will be minima.
Okay, that will happen by substitution.
How many maxima, how many minima, I can't tell.
Okay.
There are right now 4 maximas, 3 minimas. They can also be 4 minimas and 3 maximas. No, then also 7.
Yes.
But one thing we can say for sure. A maxima will lead me to a minima, will lead to a maxima, will lead to a minima, will lead. There's no other choice in between. In between any two maximas, I have to approach a minima and come to the next maxima, right? Correct? So my point is, for any two maximas, there should be one minima in between. And for any two minimas, there should be one maxima in between. Therefore, either this will come as a combination of 4 plus 3 or 3 plus 4.
Yes.
For x power 8. If all roots are real.
Okay.
Are you getting my point?
Yes.
So yeah, we can have more than one, we can have more than 2, more than 3. Okay, maximum minimas, more than 4, more than how many ever. That's why nth differentiation is also there. But not for us right now. For this particular x to the power 3, you know you will get two values of x if determinant is greater than 0.
Yes.
Correct? You have solved in your school where the determinant becomes less than 0 and we call it imaginary roots.
Yes.
If my determinant is greater than 0, for a x cube polynomial, I should always get two values, one which will be a maxima and the other will have to be a minimum.
Minima.
Now, where it is, what it is, and all, we have to solve it over here in this portion. Is this clear?
Yes.
So I'll give an equation to you, polynomial, x to the power 3 only. But now I am giving a little bit of masala for it. Okay. So 114, right?
Yes.
The pressure of a gas is a function of volume and the function follows as it is given. P is equal to V cube plus 6V square minus 10V plus 2. The pressure of a gas is a function of volume and the function is given as P is equal to V cube plus 6V square minus 10V plus 2. Find the maximum pressure and minimum pressure. Find the maximum pressure
And minimum pressure.
and minimum pressure. So the first differential with respect to volume is basically 3V square plus
12V
12V minus 10, and we equate it to 0 for our maxima and minima. Now for this quadratic, my solution is minus 12 plus or minus root over B square minus 4AC divided by 2A, which is 6.
Yes.
144 plus 120 is 260.
16. Oh, wait. I wrote 164 instead of 264. Oh.
Pause. Wait. Relax. साथ में करते हैं. साथ में करते हैं. बंद कर दो. बंद कर दो किताब. किताब तो बंद करो.
कर दी बंद.
Okay. So under root of 260 is approximately.
What is closest to
225 is 15 square.
225 is 15.
16 square is 296, I think.
Yeah.
Right?
It's like 15 point
something. Let's take it 15.5.
15.5.
So basically, we will approximate this to minus 12 plus or minus 15.5 divided by 6. Therefore, I will get two values of volume. One V1 is equal to minus 27.
Minus 27.5 by 6.
Divided by 6. 6 4s are 24. 6 5s are 30. So 4.5.
Yes.
Right. So again, approximately minus 4.5. Whatever units of volume is, I wanted to give the units also. We can take pressure is in bar and volume is in meter cube. So this I will write it as meter cube. Similarly, my V2 is going to be approximately 3.5 divided by 6. 6 6 are 36.
36.
So we can approximate it to 0.6, right?
Yes.
Now, we got two values of V1 and V2. We don't know which is maxima, which is minima, right?
No.
So the next thing I'm going to do is
second differential.
Second differential, d square p by dv square. And what is it going to come?
6v plus 12.
6v plus 12. Now, to know which is a maxima, which is a minima, what will I write? For v is equal to minus 4.5, what is my second differential? That is f double dash of x. Again, my minus 4.5 into 6 is here only. Is minus 27.5.
Minus 27.5 plus 12. Which is minus 15.5.
Minus 15.5. Next, for v is equal to 0.6. 6 into 0.6, we got it as 3.5 in the numerator.
3.
3.5 plus 12.
Again, 15.5.
How much are we getting?
15.5.
15.5. Actually, we are getting these values only, right? The
Yes.
determinant values. Great. Either way, that's not our problem. So this tells me f double dash is negative. That means at this point I should have a maxima. And obviously the other fellow will become a minima, correct?
Minima.
So now I want to find closed book solving pressure maxima and pressure minima, correct?
Yes.
So what is for maxima? I have to substitute V is minus 4.5. So maximum pressure is equal to, tell me what should I substitute?
Maxima. So the equation.
The value of minus 4.5 I will substitute in
the equation. Yeah.
Equation. So I will get minus 10V plus 2. You will get some answer to this.
Yes.
And what is the minima? I'll substitute 0.6, right, in that equation. So 0.6 whole cube plus 6 times of 0.6 whole square minus 10 times of 0.6 plus 2, and I'll get a value. Fine?
Yes.
I will give you another question. Don't be in a hurry. Solve it आराम से. कोई जल्दी नहीं. कोई कहीं भी नहीं भाग रहा है. Okay? Relax. No problem.
Okay.
It's okay. I mean, okay.
A stupid mistake.
But let us now consider. See, pressure and volume basically will come in fluid mechanics. Will come in heat chapter. Okay. Now let us take something which you are probably not familiar with, which is electric field as a function of potential, electric potential. What is electric field? What is electric potential? God knows what this fellow is giving to me. Suno.
Yes.
Electric field E is given as a function of electric potential, as potential also we represent by V only, as V cube plus 2V square minus 10V plus 20. Okay?
Yes.
Where electric E is the electric field. Okay?
Yes.
Where E is the electric field and V is the electric potential. Okay? So closed book, peace of mind, relaxed manner. Old habits die hard. So V is electric potential. Okay?
Yes.
You can start solving when I will request you. Okay, you can start solving right now. The unit of electric field, just for fun, I am giving it Newton per Coulomb.
Yes.
Okay. And the electric potential is
volts.
You can use volts. Find maximum electric field or minimum electric. From where should I start?
First differential.
First differential.
So dE by dV
is equal to
3V square plus
3V square plus 4V minus 10. And it should be equal to 0 for maxima minima. Next, the solution for
quadratic formula
is minus 4 plus or minus root over B square minus 4AC divided by 2A. 120 plus 16 is 136. 144 is 12 square, so 11.7 less.
Yes.
So approximately minus 4 plus or minus 11.7 divided by 6. So the one value I will have V1 is equal to, again approximately minus 15.7 by 6.
15.7 by 6.
So 6 2s are 12 and 6 6 are 36. So
Yes.
approximately this is around
2.6.
लिख ही लेता हूँ मैं minus 15.7 divided by 6. So 12
Minus 2.6.
2.6. Okay, fine. So approximately minus 2.6. And V2 again is approximately
7.7 by 6.
is coming out to be
1.3
के आसपास.
Okay, yeah.
7.8 is 1.3. So now, what's the next step?
You substitute these values into the equation.
Which equation?
The equation for E.
The equation for E.
Yes.
But before that, I need my double differential also.
Oh. Yes.
To know if it's a maxima or a minima.
Yes.
So I will differentiate that fellow and 6v plus 4.
6v plus 4.
And anyway, you know 6v, I'll get this number only, right?
Yes.
So 6 times at v is equal to minus 2.6. My 6 into minus 2.6 is minus 15.7 plus 4 is minus 11.7.
Minus 11.7.
My double differential is minus 11.7. And at v is equal to 1.3. 7.7 plus
Yes.
4 is again 11.7.
Yes.
So I really don't have to do much of mathematics here because I'm getting the determinant value directly.
Yeah.
So now, here I can say my double differential is negative at v is equal to minus 2.6. Therefore, this should represent what?
Maxima.
Maxima. And the other fellow automatically will become a minimum. Therefore, because I got a proper conclusion that at v is equal to minus 2.6, I will have a maxima. At v is equal to 1.3, I will have a minima. Therefore, I can say my E maxima is equal to I will substitute minus 2.6 in the original form.
2.6. Yes.
So I will have minus 2.6 whole cube plus 2 times 2.6 whole square minus 10 times 2.6 plus 20. Similarly, my minima will exist when I substitute 1.3 over here, correct? Yes. 1.3 whole cube plus 2 times 1.3 whole square minus 10 times 1.3 plus 20. I want to tell something over here. This is the third problem that we are solving and the procedure is the same.
Yes.
If I can substitute these values, do the solution, I will get 100, I will get 200. Automatically, I know this is minima, that is maximum.
Yes.
If I get here 500 and if I get here 20, I know 500 is the maximum value, right? And I know 20 is the minimum value. But in mathematics, it is useful for us to know at what x I have my maximas and minima. So that I don't have to solve this entire polynomial and then. Are you getting my point?
Yeah, get the whole, yeah.
For mathematics purpose, once I get at what value do I have maxima, at what value do I have minima without doing all these long things, there will be further usage. From there, I will take another turn and solve something in mathematics.
Yes.
Right now, for our purpose, all I need is maximum minimum value. I am getting it. No, why are you forcing me to do that? I will substitute. It's not wrong. I'll substitute, I will get 500. I'll substitute, I got 20.
Yes.
Somebody, I know automatically this is maximum value, this is minimum value. Sir, anyways, I have to substitute. Why are you telling me that stuff? Because in mathematics, you will use. Also,
Yes.
if he will ask you only at what potential do I have a maximum electric field and at what potential do I have a minimum electric field, I don't have to go through this solving, and directly I can tell from there.
Yes.
So that information for mathematics purpose is actually more useful. And even for my problem solving also, if he doesn't ask me literally maxima minima and ask me at what potential will I have a maxima, at what potential will I have a minima, it's better I go that way.
Yes.
Three things. One, I will get habituated with it, with the procedure. If I get habituated with the procedure, there is very less chance I go wrong. Two, because I am habituated with the procedure, when I face that in mathematics, that will not be alien for me.
Yes.
And the third thing is, if he is not asking me the values itself, I don't have to solve everything. I can know it. So for all three purposes, it's better to follow the procedure the way it is.
Yes.
I never try to invent anything in this in my entire journey. Because it is not necessary and because it is important, I always follow the same procedure since my childhood to my budapa.
Yes.
Have fun. So you got the values right?
Yes.
Okay, you just missed this part.
Yeah.
Hi guys, I hope you enjoyed the session. If you think this video was useful, don't forget to like, share and subscribe to my channel. Also, I'll be waiting for your comments in the comment section. See you in the next video.